Hi everyone, welcome back to Job One for All. And in this video, we're going to start talking about polymorphism. We need quite a huge setup. So basically, this video will be setting up the scenario where polymorphism will be useful. Let's start creating a new package. This package will be called polymorphism.domain. Now, we are going to create a new class here called product. Product in our example should never exist. Only the classes that are implementing, in this case extending the product. So we want product to be an abstract concept. You know how to create abstract concepts in Java. Abstract class. Now we need two attributes: protected string name, the name of the product, protected double value. And we want a constructor with both attributes, and we are going to provide only the getters. We are not going to change any data inside the object, so only the getters to retrieve the data. Okay, so there is a thing. When we have products, we usually have taxes, and we have to calculate that taxes somehow. For example, let's say we have here a computer as a product. Create a Java class. Computer is a product, so you have to create a constructor matching the superclass. And we also have the get name and get value. And let's create another product here, and let's call them tomato. Tomato is also a product. And we also need to create a constructor matching. So we have several types of products, and what they have in common is they have a tax value that we should calculate over the value. Now, how can we do that? Well, we could add here inside product something that would calculate the taxes for us. So how can we actually do this? We could just add one abstract method and force computer and tomato to override, or we can do even better. We can create an interface. Let's create a new interface, and let's call taxable. Taxable has only one public abstract double calculate tax value. So I know that whoever implements taxable will have to calculate the tax value to be paid. Now, I could implement taxable in tomato or computer, but the product itself is taxable. So we can come here to abstract class and implement taxable. So now we have two problems, but not in the product itself. So the first problem that we have is in computer and then tomato. Why don't we have a problem in product? Because product is abstract, and then because it is abstract, we don't have to provide implementation for the method defining the interface. So we have to go to computer and provide the implementation. Now, what will be the tax value? Let's do something. Let's create here public static final double tax percentage, and computer, if you are in the Netherlands, it's 21%. So basically the tax value will be the value, so this dot value multiplied by tax percentage. And we are going to do the same in tomato. I will just copy this one. And let's say tomato, the tax percentage is 6%. And we are going to provide implementation for calculate tax value. And then we are going to calculate here by adding the this dot value multiplied by tax percentage. Cool. We can even add here salt, calculating tax value for tomato, and we copy this in computer. Okay, so pretty straightforward. We have a product, interface taxable, and tomato and computer as subclasses of product that are providing implementation for that taxable interface, calculate tax value method. Okay, now we are going to do a little bit different from what we have been doing so far. I want to introduce you the concept model view controller. It's something that we use all the time, especially when developing for web. Basically, it's related to coupling. We would like to have our code really decoupled from each other, and we would like to have as much as possible high cohesion. So it means that we are just splitting the responsibilities into different classes and different packages. In our case here, we have the domain classes that they represent the model. Usually is what you will be mapping the domain to the database. And if we are talking about web application, we would have the controller. The controller is something that would do the business logic between the domain and the view. So MVC is basically a design pattern that you are separating the responsibilities. So we want to separate the responsibility of calculating the taxes. We would like kind of a report, and we will create a new method, a new class only for that. And the test will behave as the view. So basically, the responsibility will be in a different place, not in the test anymore. So let's do that, and let's create a new class, a new package, and this package will be called service. So instead of domain, service, and here we are going to create a class, and this class will be product tax report. Okay, so product tax report will have two methods to calculate the tax report for both product and tomato. And we're going to create here public void. It's going to be called not calculate, generate computer tax report. And if we are generating a computer tax report, we are going to ask for a computer. Okay, so computer dot calculate tax value, and we can call this tax value. So when we execute this, we will have in the console calculating tax value for computer, and then here we can print salt at the beginning, starting the report for computer, and then at the end salt computer dot get name value. We could call value price. I think yeah, it's better to call value price. So if you want to do this kind of refactoring, fortunately for us, IntelliJ is going to do a great job. Just select here the value, press Shift F6. Refactoring is part of everyday's life, and then you change to price. And when you press enter, it will going to start. Do you want to also rename the get value to get price? Yes, I want. Do you also want to rename the price, the value attribute to price inside of the constructor? yes, I want. And then everything now is the way we want. So at the text report, we can change here to price. If you want, you can also change the calculate text value. I think value we can leave it. So price, and then tax value. What's the tax value that we have to pay? Tax value. Cool. Now we have a report for computer, and we have two classes. We are going to duplicate this and generate tomato text report. Starting the report for tomato. And then we are going to change here tomato. So I will copy this. So tomato, calculate text value, and now tomato.get name, price, tomato.get get price, the same thing here, get price, and text value. Basically the same report, but for different products. And now we are going to work in the test. The test is kind of the view. So what we are going to see, and we're going to create a new package called test. And we are going to create a new class called product test 01. PSVM, we need to first create the products. Basically, imagine that we are inserting to the database. Let's start with computer, new computer, and we can give a name. Let's say this is NUC 10 i7, and the price will be 8,000. And we are going to create a tomato, new tomato. So this tomato is Italian, and the price, let's say per kilo, maybe we paid $5. Now we have both products, and we need to generate the product text report. Now, do you need to create an object just to execute these methods? Well, the way it is now, we have, but remember from the static class, we can make all the attributes, all the methods that are not accessing any instance variables static. So in this case, we can make this guy static and this guy also static. Now let's go to our product test. Let's call the report. I'm sending a computer, and I will generate now the report for tomato. Cool. Let's just give a small line between the reports, and then Ctrl+Shift+F10. We can see that the report for computer, calculating the text value for computer. The computer is a NUC 10 i7, price 1,000, and the text value 210. And starting the report for tomato, the text value for tomato, the tomato Italian, $5. The report says that we have to pay the tax value of 0.3 or 30 cents. Okay, so this is the setup that we are going to use. So it's important for you to understand everything that happened. So let's go over once again. We first started creating a product. Since the product should never be instantiated, we made this class abstract. This will avoid people creating new products. So once we do this, we are basically saying, okay, product will never be instantiated, but we do need other classes. That's why we made this abstract and started creating computer and tomato that are basically products, but one extension. It means that we are adding more functionalities to the product itself. Now that we have both of them, we had to calculate the taxes. So all the products, they should be taxable. That's why we first created one interface, and this interface taxable became was implemented in the product. But since product is abstract, we have the option to not provide an implementation. So imagine that we are living in a country where we only have one tax for everything. So we could provide the implementation here. But since each product will have a different tax, we provided in the subclasses. That's why we have here computer and tomato. And then we are splitting the responsibilities, and the responsibility for the product tax report is inside a specific service. So if you want, you can even call this by pressing Shift F6 and refactor to service. Then it will make even more explicit that this is a service class that's basically doing business logic. And we created two methods, one for tomato and one for computer, where these methods are just going to print a tiny report. And then if we go back to product here, product test, we are just calling the creating two objects and calling the generate computer and tomato text report. So this is our setup. In the next video, we are going to start talking about polymorphism and how to make this code better. So see you there. Bye.